working on the homework here. Number one, consider the graph shown in the figure, which gives the velocity of an object moving along a line. So this is v of t. Assume time is measured in hours and distance is in miles. The areas of three regions bounded by the velocity curve and the t-axis are given here below. We'll use this color. Completes parts A through E. On which interval is the object moving in the positive direction? And so this means when is v positive? Right. So when the so let's be clear, the velocity versus the speed. The speed is, for instance, if I'm driving, I just look at the speedometer and it says 65 miles per hour. That's my speed. My velocity is 65 miles per hour north, right? So velocity is speed with a direction. In this case, the direction is given by the sign. If the velocity is positive, you're moving to the right or in the positive direction. If the velocity is negative, you're moving to the left or in the negative direction. So this is the graph of the velocity. So this is the interval 0 to 2 union with the interval 6 to 10. Just where the velocity is above the x-axis. Select the correct choice below, and if necessary, fill in the answer box to complete. The object is moving in the positive direction on the intervals. Okay, we answered that. Use the values shown in the graph to set up an expression that gives the displacement of the object over the interval 0 to 6. So what they want us to write is 12 minus 15. The expression 12 minus 15 gives the displacement of the object over 0 to 6. A bunch of blue plus stuff minus a bunch of um, red 15 stuff, negative stuff. The displacement over the object over the interval is going to be -3. Using the values shown in the graph to set up an expression that gives the total distance traveled by the object over the interval 2 to 10. Same thing. So then it's going to be -15 plus 10. Oh, this is probably miles. -15 plus 10. And then you're right, -5. Oh, do not perform the calculation. And then the total distance over the interval 2 to 10, the object travels a total distance of 2 to 10, 25. Oh, wait 1 second. The total distance traveled, you're taking the positive. That's 15 plus 10. And that is 25. Use the value shown in the graph to set up an expression that gives the displacement of the object over the interval 0 to 10. Over the whole interval, I have some plus 12, some minus 15, and a plus 10. The displacement is, just add that up, 7. So that person is 7, I believe it's miles, away from where they started. Describe the position of the object relative to the initial position. It is to the left of its position after 10 hours. It is to the left of its position if its displacement after 10 hours is negative. It is at its initial position if that quantity is 0. It is to the right of the initial position if that quantity is positive. Select the correct choice below, and if necessary, fill in the answer box to complete your choice. After 10 hours, the object has returned to its initial position. Nope. After 10 hours, the object is, it's not to the left. After 10 hours, the object is 7 miles to the right. There are all the choices. The figure shows the velocity function for motion along a line. Assume the motion begins with an initial position of s of 0 equals 1. Determine the following. Right, so this is the velocity. Now we're going to be thinking about the position. So while we're here, let's just be clear that by the fundamental theorem of calculus, s, which we don't know, is equal to s of 0 plus the integral from 0 to t of v. S, oh, s is a letter v of x dx. Oh, we can do s of x, v of t dt. And so what is this saying? That we have the initial value. The initial value here is 1. And then the integral from 0 to x of v of t dt, this is just the area under the curve. And the x-axis. So all we're doing are counting boxes. Let's be clear about what a box is. It looks like it is 1 by 1, right? So each one of these is 1, right? 4 to 5, 4 to 5. Okay. The displacement between t equals 0 and t equals 10. T equals 0 and t equals 10. So it wants to know the integral from 0 to 10 of v of t dt. And so here, all we're going to do is find this area here, this area here, this area here, right? And just add up the whole thing. And so here, this area, half the base times the height. Height's 4. 4 times 2. This area here is 4. Right? So then this is 4 down, 1 over. This area here is 2. We just have to remember it's negative. Here, this is 3 to 6, and this is still by 4. So that's 3 by 4. That is 12. This here should also be 2 if there's any justice about symmetry. So that's 1 by 4. That area is 2. And then we need this. And it looks like, again, this is 7 to 10. That's 3 by 4. That's 12. Half the base times the height. That's 6. All right, so this here is negative 14. That's 4. That's 6. Looks like negative 4. Right, so 1, 2, 3, 3 by 4. Yeah. Okay. The total distance traveled from t equals 0 to t equals 10, just add that stuff up, 24. Right? So all this blue stuff right here just becomes positive like this, right? Like this, right? And you're just adding up the positive 14 instead. The position at time t equals 10 is, the position is negative 4 plus wherever you started. displace 4 units to the left. And now, so yeah, this is just -4 plus 1, -3. And so for D, the question is, what is the antiderivative of this function? So they give us two choices, and so we can test which one is which. These look roughly the same, except both here and here, right? So here and here. So let's see what's happening on the interval 3 to 6. From 3 to 6, the function looks constant, so its antiderivative should be a line, right? So this is -4, right? The antiderivative of -4 is -4t plus a constant. Which one of these is -4t plus, ooh, it's A, -4t, all right? And so that eliminates what's going on here. So we can also see why it wouldn't be -4t plus 15 from 8 to 10. From 8 to 10. The antiderivative of this line should be a quadratic. Number 3, the function v of t equals t cubed minus 10t squared plus 24t 0 to 8 is the velocity in meters per second of a particle moving along the x-axis. Complete parts A through C. Determine whether the motion is in the positive direction and when it is in the negative direction. So again, we got technology to graph this. We'll do this one by hand though, just in case you run across somebody who's going to be like, no, you have to do this by hand. It's t cubed minus 10t squared plus 24t. When it's asking whether it's moving right or left, we're asking whether v is positive and when v is negative. We'll factor t times t squared minus 10t plus 24. We'll keep factoring t times t minus 6 times t minus 4, and then we can do a number line. So this is equal to 0 when t is, let's put 0, 4, and 6, and then we can test some points about the derivative. So this then becomes a first derivative test type thing that we just pick values in each one of these intervals. So if I pick here, they only care about 0 to 8, and so we can just start here, 0 to 8. And so now if I pick a number like 1 and put it in this thing, then it's going to be 1 times -5 times -4. That is a positive. If I pick 5, then it's 5 times -1 times +1. That's negative. When I pick 7, then it's going to be 7 times 1 times 3. That is positive. Motions in the positive direction, 0 to 4, union 6 to 8. Negative direction, 4 to 6. Find the displacement over the given interval. The displacement over the given interval is the integral from 0 to 8 of the function. 0 to 8 of t cubed minus 10t squared plus 24t dt. As you may know, we're going to roll to a new page for that. straight up using the fundamental theorem of calculus, this is equal to the antiderivative of t to the third is 1/4 t to the fourth minus 10 over 3 10 to the third plus 24 over 2 t squared evaluated from 0 to 8. The 0 is very useful here. We'll plug that in and get nothing. But then when we plug in 8, we get 1/4 times 8 to the fourth minus 10 over 3 times 8 to the third plus 24 over 2 times 8 squared, whatever that number is. Right, so just simplify and plug that into MyMathLab. So that's just all calculated. And so then for the total distance, we'll need this number line as well. We'll take the number line and we'll get we'll also need the function. Oh, we can also put it here. So then we'll put it on the same page here. So then for the total distance, then we'll need to do the integral from 0 to 4 of t to the third minus 10t squared plus 24t. That's where it's positive. And then we'll need to do minus the integral from 4 to 6 of t cubed minus 10t squared plus 24t dt. And then plus the integral from 6 to 8 of t cubed minus 10t squared plus 24t dt. Right, and so again, the reason why this minus sign shows up is because for the total distance, we need positive areas. I know that the function was negative on this interval, and that is why this minus sign I need out front makes it positive. And so then you would calculate these three intervals, and then that is the answer. Again, and add. And this again, all using fundamental theorem calculus. It's helpful again that you will have the antiderivative will be here. You will have already done it, and you'll just need to plug in the endpoints on three separate occasions, and on this one, change the sign. A cyclist rides down a long straight road at a velocity. So there's the rate. It's 100 minus 10t on 0 to 10. How far does the cyclist go in the first 4 minutes? And so here we've got just the integral from 0 to 4 of 100 minus 10t. And so dt. And so this is going to be equal to the integral. Oh, let's do the antiderivative. 100t minus 10 over 2t squared from 0 to 4. 100t minus 5t squared from 0 to 4. Plugging in 4. 100 times 4 minus 5 times 4 squared. 400 minus 80, 320. For 7 minutes, same thing. You just do the integral from 0 to 7 of 100 minus 10t dt. So that's 100t minus 5t squared from 0 to 7. Plug that in. 100 times 7 minus 5 times 35. I'm sorry, 5 times 49. 700 minus 245, 555, 455. When the cyclist's velocity is 75 meters per minute, he has traveled how far? So you need to find this time first. When is the velocity 75 meters per minute? So you need to set 100 minus 10t equal to 75 and solve. So minus 10t equals negative 25. That is 2.5 seconds. So then you would integrate from 0 to 2.5 of 100 minus 10t. So again, 100t minus 5t squared, evaluated from 0 to 2.5, and you find out what that number is. 100 times 2.5 minus 5 times 2.5 squared, and then round that to 2 decimal places. So then finding the time and the velocity is what you are asking for, and then doing the integral up until that time. Fundamental theorem of calculus. Classic problem here. We got the acceleration. They want to know the velocity. The acceleration is constant. It's negative 32. The velocity is the initial velocity plus the integral from 0 to t of the acceleration. A of x dx. Right? So the antiderivative of a of t, so b of t is equal to negative 32t plus the initial condition, which is 40. And then the antiderivative of that is negative 32 over 2 t squared plus 40t plus the initial condition in this case is 20. 16t squared plus 40t plus 20. It's taking the antiderivative and plugging in the initial condition. Starting with an initial value of p is 0 equals 20, the population of a prairie dog community grows at a rate. Here's the rate. And so we want to know 14 months later. So we want p of 14. P of 14 is equal to the initial amount, which is 20. And then it's going to be the integral from 0 to 14 of 30 minus t over 2 dt. Fundamental theorem of calculus. The initial amount plus the integral. This is equal to 20 plus the antiderivative of 30 is 30t minus 1/4 t squared, evaluated from 0 to 14. 20 plus 30 times 14 minus 1/4 times 14 squared minus, when you plug in 0, you get 0, whatever that number is. So that's 20 plus, that is 520 minus whatever 14 squared is over 4. 14 times 14 equals divided by 4, 49. Whatever that is. The population P of t for 0 less than equal to t less than equal to 60 is P of t is, so we'll just calculate what it is, the antiderivative of 30t. So we need the integral of 30 minus 1/2 t dt is 30t minus 1/4 t squared plus a constant. We know that at 0 it's supposed to be 20. And so if this is P of t, P of 0 is 20, means that C is 20. 30t minus 1/4 t squared plus 20. Just finding the antiderivative and plugging in the constant. Area between curves. Set up a sum of two integrals that equals the area of the region bounded by the graphs of the functions f and g on a to c in the figure. Assume that the curves intersect at x equals b. Well, from here, it looks like we're going to do the top. Again, it's always the top function minus the bottom function. So this looks like the integral from a to b of f minus g plus the integral from b to c of the top function g minus f. As my brother had asked earlier, how do you know? In this case, you're given the picture. Which one is that? A to b, f minus g, b to c, g minus f. They're making it easy. In the figure to the right, the equation of the solid parabola is x squared minus 11, and the equation of the dashed line is y equals 10x. Determine the area of the shaded region. Again, one of these is a parabola and the other one is a line, and it looks like the line is the higher function. We need to find out where these two intersect. So this is going to be some integral from a to b of the top function, which is 10x, minus the bottom function, which is x squared minus 11 dx. The only question, of course, is where are a and where are b? And of course, they're going to set this up pretty nicely. So we need to find out where these two intersect. We'll get everything on one side of the equal sign. X squared minus 10x minus 11 needs to be equal to 0. And of course, we set it up so that you can factor. Factors of 11 that are 10 apart, 11 and 1, minus sign on the 11, plus sign on the 1. And so we're talking equals 0. And of course, we're talking about x equals 11, or x equals negative 1. This is the integral from, we're going to need some space. This is the integral from negative 1 to 11 of 10x minus x squared plus 11 dx. This is equal to, by the fundamental theorem of calculus, the antiderivative of 10x is 5x squared minus 1/3 x to the third plus 11x, and then evaluate it from negative 1 to 11. Super ugly number. Plugging in 11 and negative 1 and subtracting, we'll get 5 times 11 squared minus 11 cubed over 3 plus 11 times 11 minus 5 times negative 1 squared minus 1/3 times negative 1 to the third plus 11 times negative 1. And then you just have to do all that arithmetic. For the exact answer. So yes, tons of work with the fractions, and that is how it goes. Again, as was being mentioned earlier, how do you know which one's the higher one or which one's the lower one? It is about context here. We've got a quadratic with a negative sign in front. That means it opens up like this. This is a quadratic which opens, and that opens down like that. This is a quadratic that opens up. There's the picture there. We know which is which. Again, this is going to be more of a question of where these two will intersect. which in this case is this going to again be a quadratic equation. The hope is that we'll be able to factor it. Looks like on where they do intersect, the blue graph is higher. The blue graph is the one with the negative exponent, the negative coefficient of x squared. Negative x squared plus 7x minus x squared minus 3x dx is a representation of the area between those two curves. Again, the question is what is A and what is B? We'll find A and B by setting them equal to each other, the two functions, as this is where they will intersect. The fundamental theorem of algebra says that you're going to have two answers here, most likely. We'll move everything to one side. This is 2x squared minus 10x is equal to 0. Adding x squared to the right, subtracting 7x to the right. They both have 2x in common. X minus 5 equals 0. X equals 0, or x minus 5 equals 0. This is the integral from 0 to 5. The integral from 0 to 5 of negative x squared plus 7x minus x squared plus 3x dx is equal to the integral from 0 to 5 of negative 2x squared plus 10x dx. This is equal to, by the fundamental theorem of calculus, negative 2/3 x cubed plus 10 over 2 x to the second, evaluated from 0 to 5. Plugging in the 5 to 0 and subtracting, this is minus 2/3 times 5 to the third plus 10 over 2, 5 to the second, minus 0. Plugging in 0 gets you nothing. That might turn out to be nice. 250 over 2, 125. So this is minus 250 over 3 plus 250 over 2. And you just reduce that with the fraction. Oh, great. All right, excellent. All right, we'll stop the recording there.